Okay, so let's go ahead and get started. So today we're going to talk about straight lines and vectors, pretty much everything to do with straight lines and their equations. And then we're going to see what kind of time we have left to go into vectors. Maybe we'll kind of work on some of the grade 8, 9 level problems for those mostly. But yeah, we want to make sure that we understand what a straight line equation is going to look like, what types of things we can do with them, what we could expect to see as an exam question. So we'll go through all of that. Okay, so if we take a look at the first couple of starter questions that we have, let's go ahead and solve them. They're not too bad to start us off with. So we've got our equation here. We've got y is equal to 3x plus 4. Our gradient, okay, and let me go ahead and write down our general equation for a straight line. It's y is equal to mx plus b, okay? So y is equal to mx plus b. So in this case, our m is going to represent our gradient, and in this case, it's going to be 3. So m is equal to 3, or your gradient. So our gradient is equal to m, which is just 3. And then if we're looking at the y-intercept, that's going to be our, oh, sorry, I keep forgetting I'm in the UK now. We use mx plus c here. So mx plus c, we use b in Canada. So our c value in this case represents what we call the y-intercept. Okay, so our y-intercept is going to be the point where our graph crosses the y-axis. Okay, so in this case, since it's a positive 4, I can say that c is equal to 4. So our point is at 0, 4. So our y-intercept is going to be when x is 0 and y is equal to 4. So this is where our graph would cross the y-axis here. Okay. So going the opposite direction, if we're taking a look at this graph that's given to us, okay, we want to be able to go the opposite direction. We start off with the graph and be able to come up with its equation. Okay. So again, keeping in mind that our general form of some sort of straight line is y is equal to mx plus c. So what we can do is we can start off by identifying our c value. So in this case, we can see that our graph crosses at positive 1. So we can therefore write our c value. We can say that c is equal to 1, and we can see that it's at the point 0, 1. Okay, and I'm going to use that point in just a second here as well. The next thing that we need to do is figure out our gradient. So remember, our gradient is our value of m. So looking at our graph, we can do this in a couple different ways since we have a graph with a scale of 1 to 1. So that means that if I go 1 in this direction, right, every square that I go here, that I move across, it's just 1, and we're just going up in ones. And same thing moving along that y-axis as well. So I'm free to just be able to do something like this. I can start off at 0, 1, and I can say that my rise over my run. So I'm going up 2 in this case, and I'm going to move 1 across, and I can find my next point right there. Okay, so my next point right there is going to be at 1, 3. So once again, my rise is equal to positive 2 because I've gone up 2. And my run in this case is a positive 1 because I moved across 1. So since gradient is equal to rise over run, I have 2 over 1, which is really just 2. So in this case, my m value is equal to 2. And we can write our equation of line L as y is equal to 2x plus 1. Okay. So the alternative way that we could have done this as well is by using our other formula for gradient. So if you do recall, our other formula for gradient is m is equal to y2 minus y1 over x2 minus x1. Okay, so looking at our 2 points again, I'm just going to go ahead and rewrite them here. So I had 0, 1, and 1, 3. And essentially what we want to do is just pick one of the points or one of the coordinates to become our x1, y1. So usually I go left to right. So in this case, because this one's the furthest most on the left, I'm going to call this x1, y1, and this will be x2, y2. And all we need to do from here is just substitute in those values. And my y2 in this case is 3. And I'm going to subtract my y1, which is just 1. and I'm dividing this by my x2, which is 1, and my x1, which is 0. Okay. So we can continue on along with this. We'll see 3 minus 1 is just 2, and 1 minus 0 is 1, which again gives us 2. Okay. So if we see our gradient as a fraction, okay, 2 over 1, just note that this means 2 up and 1 to the right. That's how we would interpret this. If I were to extend this example, if I said that our slope for a different line was negative 4 over 7, what this means is that we're going to go 4 down and then 7 to the right. Okay. So again, if we're moving up, it's going to be positive. If we're going down, it's negative. If we're moving to the right, it's going to be positive. We don't really move left when we're talking about gradient. The only way that we would do that is if we said, okay, let's work backwards from, let's say, this point. How do I get to this green point over here? We'd go 2 down and 1 left. And you can see that if we were to go the opposite direction, we'd make a triangle just going the opposite direction. Okay, so that's a very, very quick start to straight lines. Are we feeling okay about everything that I've just kind of ran through here? Because I want to get to the good stuff. Um, can I get a thumbs up in the chat if we're feeling okay with those ideas? All right. Sounds good. All right, so let's take a quick look at something that might be slightly more difficult. Okay, so something a little bit more abstract here, where you're just given some sort of equation and you have to be able to find both the gradient and where it crosses the y-axis, but you're not given this equation in its general form. Okay, so we're going to start off with this question here, and we'll see if we can figure out how to do it. Okay, so we have a line with an equation of 6x plus 2y plus 9 is equal to 0. So again, comparing this with our general equation of a line, so y is equal to mx plus c, we need to be able to make y the subject in this case. All right, so I'm just going to do this over here on the side. So we have 6x plus 2y plus 9 is equal to 0. I'm just going to go ahead and move the 6x over to the right-hand side. So I'm going to subtract 6x. So I'm left with 2y plus 9 is equal to negative 6x. I'm going to then subtract 9. I can do this both at once if you guys would like. But just for the sake of thoroughness, we'll do it separately. So minus 6x minus 9. And then we simply divide both sides of the equation by 2. So we end up with y is equal to, and let's take a look at this separately. So negative 6x over 2. Let's actually split this up because I've had some students ask me how we would be able to do this. So we just split it up into 2 fractions. And negative 6x divided by 2 is negative 3x. And negative 9 over 2, I'm just going to leave as negative 9 over 2. If you want to write it as a decimal, that's also fine as well. So we could have it as minus 9 over 2, or y is equal to negative 3x minus 4.5. Okay. So what the question was asking us is, what is the gradient? So in this case, our gradient is going to be our m value. Remember, it's the number that is beside the x. We call that the coefficient. So it's a negative x, or sorry, negative 3 in this case. So let's go ahead and write negative 3. And then where does the line cross the y-axis? Remember, it's going to be our c value. So our c value in this case is going to be that negative 9 over 2 or that negative 4.5. Doesn't really matter which one you put that or put down as your answer. So you can say negative 9 over 2 or negative 4.5. Okay. Are you feeling okay about that particular example? Any questions about that? Very quiet in the chat today. That's all right. Okay, so what we're going to do next is we're going to take a look at what happens if we're just given different characteristics of the graph instead, and we're going to have to be able to come up with an equation based off those characteristics, okay? So let's say, for example, and I'll go ahead, I'll do one more with you guys before I set you off to do some practice on your own. Let's say, for example, we have a gradient, say m is equal to 4 and c is equal to -7, okay? Pretty straightforward. We know we have y is equal to mx plus c. So we've got y is equal to 4x minus 7. It's not too bad, okay? That's when they give us all of the content that we need. So let's say we have something slightly more difficult. Let's say, for example, we know that your gradient is equal to 2, and we end up having this point, and let's say that this point is 3 and 5. And what we need to do is find the equation. Okay, so for this particular example, we recognize that we have our gradient and we have a point that's given to us. And I'm just going to go ahead and label this as my x and my y, because remember, a coordinate or ordered pair always comes in x and y. And we want to be able to find this equation, let's say in y is equal to mx plus c. So I'm just going to start off with that. Y is equal to mx plus c. And we're going to substitute in everything that we know. So in this case, y is equal to 5. So I'm going to go and sub that in. We know that m is equal to 2. And we have our x value, which is 3. And we're going to, in this case, make c the subject. So 5 is equal to 6 plus c. And subtracting 6 from both sides, we get c is equal to -1. And substituting this back into our original equation of y, or general equation rather, we can come up with the equation y is equal to 2x minus 1. All right, so hopefully we're feeling not too bad about that type of question. All right, do we have any problems with finding any of those there? You're feeling okay? All right, so we're going to do some application questions here. I'm going to go ahead, put it on the screen, and give you a couple of minutes to work through this one because it is a bit more of an application question. So using what I've just talked to you guys about, let's go ahead, work through, sorry, not this question, put the wrong one on the page. We'll go ahead and toss this one onto the screen. So it says a line has equation y is equal to 2x plus 6, and the line crosses the x-axis at the point A. The line crosses the y-axis at point B. Point C has coordinates 1, 8. Can we find the coordinates of point A, coordinates of point B, and then find the equation of the straight line passing through points A and C? So see what we can do. I'll give you guys about 2 to 3 minutes just to at least get started. I would recommend maybe drawing a picture just so you can kind of see what's happening. And then we'll go from there. Okay, so let's go ahead and start off. Just curious, can you guys type what you got into the chat for your solutions for A, B, and C, just so we can see if we're on the right track here? If everyone's got the right answer, maybe I'll just kind of go through them pretty quickly. So I got -3, 0 for A. That is absolutely correct. Anyone get anything for B? 0, 2. That is also correct. Or sorry, not for that one. Sorry. We're close. Not quite. So maybe we'll start off just with the theory behind this, okay? So when it comes to first A and B, okay, so we say that it crosses the x-axis, okay, at point A. So if we're crossing the x-axis, I'm gonna go ahead and draw a little sketch here. So we know 2x plus 6 means that we have a positive gradient because our coefficient m our gradient is going to be 2. So we have a positive gradient, so our line's going to go upwards from left to right. And then our y-intercept is going to be right here at positive 6. So I can label a couple things. So right here, I know that this is going to be 6 and that my line is going to go upwards kind of like this. All right. So already a hint for B there. Okay. So I'm going to skip ahead, go to B. And we know that this point, that 6, is actually the coordinate 0, 6. Okay. And then when it comes to the x-axis, we know that point A is going to be right there. And we know that for this point, our y value is going to be 0. So we're trying to figure out what x is equal to when y is equal to 0. So what we need to do is just take my equation and substitute in a 0 for y. And we'll get 2x plus 6. Subtract 6 from both sides, and then divide both sides by 2. And I get that negative 3, hence my point for A is going to be at negative 3, 0. Okay? And then let's take a look at the equation of the straight line passing through points A and C. So there's a couple different ways we can do this. We can start off by looking. Let's go ahead and let's do this. Let's start off by writing that we have C is 1, 8. We're not entirely sure if C is on the original line. We're going to say that's probably not. Otherwise, they wouldn't ask us the question. But what we need to do is just pick one of the other 2 points, or rather A in this case. So we're trying to pick out A and C. So we have A, which was, we said negative 3, 0. And we're trying to find the equation of the line that passes through these 2 points, okay? So what we're going to do first is we're going to look for the gradient, okay, between those 2 points. So it doesn't really matter which one we label as x1, y1. So let's go ahead and do that. x1, y1. Let's call this x2, y2. And we're going to use the equation m is equal to y2 minus y1 over x2 minus x1. So in this case, we have 0 minus 8, and then negative 3 minus 1. So this gives me negative 8 over negative 4. And because when we divide two negative numbers, it becomes positive. So this actually becomes a positive 8 over 4, which is the same thing as 2. So our m value is just going to be 2. Now, there was another equation for a straight line. I'll just kind of reintroduce it here. Another form that you could also use is y minus y1 is equal to m times x minus x1. And you can see here the similarities, okay, between this equation for our gradient and this new equation that we've done, or that we've made here. You can see all we've done is we've multiplied the denominator, x2 minus x1, back up over here, okay? So in this case, what we can use this equation for is we can use, when given a gradient and a point. In contrast, if we have y is equal to mx plus c, typically we'll use this when given a gradient and the y-intercept, okay? So the difference really lies in the fact that for the first equation, you're given just some random point, and then for the second one, you're given the y-intercept, okay? So for this one, because we know the gradient and we know at least one of the points on the line, we can actually just go straight into this equation here, okay? So I'm gonna plug in C into this equation. So I'm just gonna go ahead and use this 1 and 8, okay? So I'm just gonna rewrite things down here. So we know that we have y minus y1 is equal to m times x minus x1. And we know that c is 1, 8. Now the key here is just knowing which one of these variables are we replacing. So in this case, we're actually replacing the x1 and the y1. So let's call this x1 and y1. And we simply substitute in all of our known variables. So y minus y1, which is 8. So y minus 8 is equal to my m, which in this case is 2, times x minus 1. So for those of you who are kind of wondering, well, how does this work? Does this still give me the equation of a straight line? Can I turn this into y is equal to mx plus c? And the answer is absolutely yes. You don't need to write this part down, but if I were to expand my brackets here, I get 2x minus 2 on the right-hand side. And then on the left-hand side, I can simply just add 8 to both sides, and I'll get 2x plus 6. And both of these are going to give me the same line. Have any questions about that question? That one was a little bit tricky towards the end. I want to get a thumbs up from you guys if we're feeling all right, though. Okay, got a couple thumbs up, which is good. So let's move on to some of the other things that we can do with straight lines. And then we'll move on to some tangents using perpendicular lines. And then we'll spend some time doing some vectors. Excuse me. So looking at some applications, before we move on to the applications, though, I want to talk about the differences between parallel versus perpendicular lines. Okay, so parallel lines, they have the same gradient. So they have the same gradient. Whereas for perpendicular lines, their gradients are negative reciprocals. Okay, so their gradients are negative reciprocals. So what does that mean? Let's say, for example, we have a gradient of 3 over 4. The negative reciprocal of this means that all I need to do is flip the numerator and denominator. So 4 is on top, 3 is on the bottom, and simply make it negative. Because the first fraction is positive, then the new fraction has to be negative. And the idea behind negative reciprocals is that if I were to multiply these together, so you don't need to write this part down, but if I multiplied these two together, our result is simply negative 1. Okay, so negative reciprocals, if I multiply them together, the result or a product is just going to be negative 1. Okay, so that's the idea behind negative reciprocals. I can do the same thing if I start off with a negative, let's say 5 over 7. The negative reciprocal of negative 5 over 7, let's go 7 over 5. And because my first fraction was negative, then the second fraction has to be positive. I can do the same thing with a whole number. So let's say my original gradient is 2. Then I can just pretend that I can rewrite this as 2 over 1, which makes my negative reciprocal negative 1 over 2. Okay, so that's the idea behind negative reciprocals. So we'll take a look at a few examples where we're going to put those into practice. Okay, so let's look at our first example here. Let me put it up onto the screen. Actually, I'll just write it down. Makes it a little bit easier. So we want to find an equation. Find an equation of a line parallel to y is equal to 7x minus 3. So to do this, let's start off by drawing a quick little sketch here. So 7x minus 3, we're going to start off with our y-intercept. It's going to be down here at negative 3. And our gradient is going to be 7. So because it's positive, it's going to move up. So it means that we're going up 7 and 1 to the right. So it's going to be fairly steep. It's going to look something like this. So if we're looking for a line that's parallel to this current line here, we know that the gradients have to be the same. So our new gradient also has to be 7. But the key here is understanding that parallel lines also do not cross. They don't meet, okay? So for our new y-intercept, it can be any number other than that negative 3 that we started off with. So our new equation could be y is equal to 7x minus 2, or we could have y is equal to 7x plus 1, or we could even have y is equal to 7x minus 2.999 if we wanted to, okay, because it's not the same as negative 3. All right, so really any other line there. Let's try another one where we're going to now look at something that's going to be perpendicular. Okay, so if it's perpendicular, we're going to add one extra kind of stipulation to it. We're going to add um, one extra thing into it. Give me 1 second here. So if we're looking for a line that's perpendicular to this equation, let's go ahead and put this example on. Again, keep putting the wrong picture in there. Here you go. So we need to find the equation of a line perpendicular to 3x plus 3. So before we can do anything, what do I need to find first before I can start off with the rest of the question here? What can I do? What do I need to do first? What's step number 1? Tell me all about it in the chat. We need to find the gradient. Excellent. And we know that the gradient that's going to be perpendicular to this is going to be what? I mean, to be careful, remember that we're looking at something that's going to be perpendicular. So perpendicular lines have what types of radiant or what types of gradients? Parallel lines are the same, but perpendicular lines need to be getting close, getting closer with the negative. So remember the term is called negative reciprocals. Okay, so in this case, if we're looking at our gradient here, our gradient is equal to 3. So since our gradient is equal to 3, and I'm going to use this little symbol here, it's going to look like an upside down T. So our perpendicular gradient, remember that 3 is the same thing as 3 over 1. If it's perpendicular, I can now rewrite this as 1 over 3. But because it's a negative reciprocal, I'll rewrite it as negative 1/3. Okay? Does that part make sense? So you see how we had to turn that 3 over 1 into a fraction first, and then we're going to flip the numerator and denominator. And then since it's positive, we need to make the negative reciprocal negative. Okay? So coming up with the rest of the equation, it doesn't really matter what our y-intercept is. So we could have y is equal to negative 1/3 x plus anything. Okay, I wouldn't actually write plus anything. Negative 1/3 x plus 1. Y is equal to negative 1/3 x plus 3 could also be a perfectly acceptable answer as well, as long as your gradients are perpendicular to each other. Okay, so I know that part with finding the gradient might be a little bit tricky, so I'll give you guys a couple to try out here on your own before we move on. So let's try another one here. Let's go with this question. So let me put it on the screen. This one has one extra step, so please be careful while you guys work through this one here. So let me put it on the screen for you. Sorry. And here we go on the screen. So we have the equation of a line perpendicular to y is equal to 1/2 x minus 4, and it also passes through a certain point. Okay, so there's going to be 2 steps to this question. So please be careful about what we attempt to do here. So remember, our first step is to find out our original gradient, and then we need to find the perpendicular gradient. And then we need to come up with a brand new equation with the stipulation that it passes through the point 0, 7. So can we identify what the gradient or what the new gradient is going to be first? We can go ahead and type that out in the chat. Oh, you are so close. You're missing one thing there. So y is equal to 2x plus 7 is very close and excellent. Negative 2x plus 7. Okay, excellent. So let's go ahead and for those who are still kind of working on it, okay, so we identified the original gradient as 1/2. So we can say that the perpendicular gradient, let's switch the numerator and denominator, and we'll make it negative. So negative 2 over 1 is just negative 2. And it passes through the point 0.07. So we can see here that the point 0.07 is actually our y-intercept, which means that c is equal to 7. And we have an m, our gradient, and we have a c value. Well, we can just plug that into y is equal to mx plus c. So this gives us y is equal to negative 2 plus, or sorry, negative 2x rather. Y is equal to negative 2x plus 7. Okay. Now, if I make one small tweak to this question here, let's say I have the exact same style of question. Let's do this. So write down the equation of the line perpendicular to y is equal to. So that's what these quotation marks are for. Just same thing as what we wrote down up here. But we have, instead of y is equal to 1/2 x minus 4, let's start off with something such as negative 3x plus 1. And it passes through, which passes through. And let's go with the point. Let's go with 5, negative 4. Okay, and see how we do with this question. Okay, so take a second, start to work through it, see which parts here might be a little bit trickier. Can we still find a c value, or do we need to use something else to help us out in this case? So just a note for you guys, when you are writing down your equation, you guys just need to make sure that you write down the entire equation, y is equal to negative 2x plus 7, because again, that's going to count towards your accuracy marks. If you write down negative 2x plus 7, it's very likely that you might not score full marks because negative 2x plus 7 is technically an expression rather than an equation, okay? So just be careful about that. All right. So have we worked out what the gradient of our new equation is going to be? We're able to find out the new perpendicular gradient. See if anyone in the chat is able to help out here. Negative 1/3. We're very close. Very close. So we'll point out that our original gradient is negative 3. Okay, so our original gradient is negative 3. So we can pretend that's negative 3 over 1, which means that your perpendicular gradient is now going to be 1/3. And because it was already negative, then this new gradient has to be positive for them to be negative reciprocals of each other. Okay, so just be careful of what those, of where your signs are for your gradients. It does make a big difference. Okay. Second thing that we're going to take note of is the fact that this point that we're given, right? This is just some sort of point. We have our gradient. So remember back a couple slides ago, or a couple pages back here, we said that we want to use this first one when we're given a gradient and the point, and the second one when we're given a gradient and a y-intercept. This is one of those times where we're going to use that first format. So just to write it down again, y minus y1 is equal to m times x minus x1. It's going to look like that. I'm going to say that in this case, let's rewrite that 5, negative 4 here. I will call this x1, y1. So let's make those substitutions. Y minus a negative 4. So let's be careful here. Y minus a negative 4. And that's going to equal to 1/3 x minus 5. And we can see that when we subtract a negative, it's going to become positive. So I have y plus 4 is equal to 1/3 x minus 5. Okay. So the only thing that we need to be careful of is if they say we need to express this. Okay. So this would be a perfectly acceptable answer if it says just find an equation. Okay. So if it says find an equation, this is perfectly okay. But if they say express in the form y is equal to mx plus c, we have to do some tweaks here. Okay, our first thing that we're going to do is just expand our brackets if we want. Okay, again, some people like to expand the brackets, some people don't. I actually wouldn't expand the brackets in this case. I'll just expand them first and I'll show you a shortcut afterwards. So if I expand the brackets, I get 1/3 x minus 5/3. And then here we're going to subtract 4 from both sides. So we get y is equal to 1/3 x. And now because we were going negative 5/3 minus 4/1, we have to turn the second fraction into a fraction with common denominators. So that'll be negative 5/3 minus 12/3, which is equal to negative 17/3. Okay, so we're subtracting negative 17/3. Okay, so this is my equation. This would actually be the same thing, okay, if we were to put this onto a graph. If we were to graph both of these would actually give us the same line, okay? So if you're wondering what would I do instead of expanding my brackets, I would actually just multiply everything in the equation by 3, okay? So I'll kind of show you here on the side. Don't need to write this down, but if you're feeling like you're up for knowing a new shortcut, this would be great. So what I would do in this case is I'm going to multiply the entire equation by 3. So that means on the left-hand side, I'll have 3y plus 12. And this is now going to equal, because I've multiplied this by this 1/3 by 3, those will actually reduce or cancel out. And I'm just left with x minus 5 on the right-hand side. Okay. So now I can go 3y is equal to, I'm going to subtract 12 from both sides, x minus 17. And then from here, divide both sides by 3. So I get 1/3 of x minus 17/3. Okay, and both ways are perfectly valid. It just really depends on how you see yourself doing the algebra. Okay. All right. So we are sitting at just past a quarter to 8 almost. How are you feeling about equations of straight lines? Do you want to go a little harder with them, or do you want to go through vectors? What are we feeling? I know that some of you guys have to head out around 8. All right. Chat is saying vectors. You guys are very quick to hop on the vectors here. Okay, so we'll start off with a couple of vectors, of vector problems, just to get us started off to see kind of where we're at. Because again, because I haven't taught you guys vectors let's kind of see where you guys are at. So we'll start off kind of midway into vectors. So we'll start off with a little bit of with some column vectors. So here are two questions that I'd like for you guys to start off with. So we'll move on, we'll clear the screen here. Take a look at some vectors. So we got two problems here on the screen. Let me move it down to one screen here. So you got two column vectors, and we want to be able to do some vector multiplication and adding and subtracting at the same time. So give this an attempt, see where we get to. If we're all able to more or less get these, then we'll move on to some of the harder stuff with more of the diagrams. But if this is kind of where we're getting stuck, then we'll kind of stick around this difficulty. Okay, so give those two a try, and we'll see where we get to here. I think you caught where you might have gone wrong with that. Okay, so maybe just a really quick, quick little review here while we do all of this. So, column vectors. Again, when we think of column vectors, anytime we see a column vector, it's going to be in the form x, y. So the top number here, your x, is going to tell you how far to the left or to the right your vector is going. And then for your y value, how far to the left, or rather up or down. So if it's positive, we're going up. And if it's negative, we're going down. Okay. When we are multiplying vectors, so let's say, let's go with adding vectors first. If we were just adding e plus f, we would just add them straight across. So if I have e plus f, it would just be -4, 5, plus -5, -3, and we just add straight across. Oops. So e plus f is -4 plus -5, which is -9, and 5 plus -3, which is just 2. So our resultant vector would just be -9, 2, if we were just adding the two. If we are multiplying the vectors, 5e in this case, so if I look at 5e, this just means that I have this scalar multiple of 5, and I'm multiplying it on the outside with that -4, 5. So 5 times -4 is -20, and 5 times 5 is 25. So that is what 5e is. And if we're looking at 3f, we have 3 times f, so -5, -3. So 3 times -5 is -15, and 3 times -3 is -9. And since we are now adding the two together, 5e plus 3f is then equal to -20 and 25 plus -15, -9. We're going to add them straight across. -20 plus -15 gives you -35, and 25 plus -9 gives you 16. Okay. So if you got the first one wrong, maybe give the second one another attempt and see if we can get that correct before we move on to some of the more difficult vector problems. So if I can just get everyone to confirm in the chat once they have their answer for that second question, just so I can kind of gauge how difficult I can go with these questions. So in the chat, I got an answer of 2319. If I can get other people to confirm as well. So 2319 is correct. So just note that I know you're probably typing the slash in the chat just because leaving the space is kind of weird. Just make sure that you don't ever write this as part of your answer. So if you write, what do you say your answer was? 2319. So 2319. Don't ever go 23 over 19 inside of your brackets like that. Very likely you'll be marked as incorrect. So just leave it as 23, literally on top of the 19, and we'll be fine. All right. So other than that, there's other things that we can do with column vectors. We can talk about if vectors are parallel or not. So I'll just quickly go through an example here. Um, if we want to prove that two vectors are parallel, let's say, for example, we have 3 and 12, and let's go with 1 and 4. We want to be able to prove that these two vectors are parallel. And the way that we're going to be able to do that is if I can factor out some sort of scalar multiple from one or both of them and end up with the same column vector. Okay, so we can see that for this column vector on the left-hand side, I can factor out a 3. So I'm left with 1, 4 as my column vector. So these two vectors are parallel to each other. Okay, so that's one way that we can do other work with column vectors as well. Okay, so I suspect that you guys want to do some more difficult questions, especially the ones with the diagrams that require you to label them. So I'm going to go ahead and toss one up onto the screen here. I'll give you guys a second to sketch it. Doesn't have to be anything fantastic, but we'll go ahead. Oops, once again, wrong picture. Let's put this one on the screen. All right. So we have A, B, C, D, E, F is some sort of regular hexagon with center O. Okay, so if you don't know what a regular polygon is, so in this case, a regular hexagon, it just means that all of your side lengths are going to be the same. All of your interior angles are going to be the same. Okay, so no funky shaped hexagons. So I'll give you a second there to make a quick little sketch of that. Let me adjust this so we see the full question. So I see that we already have our first couple of answers coming out. So -2a. So we'll give everyone a chance to kind of work through some of these first before I start to answer them. All right. So if we're going to look for vector AD, okay, there's a few different things that we can add on. If we really wanted to, we can actually draw lines through the rest of the hexagon as well, just so we can spot some similarities. But typically, what I like to do when I'm working through these types of questions, I'll like highlight it or something, just to give myself an idea of where I'm going with my vectors. Okay. So for this particular question, we can actually just go ahead and we can just draw the rest of our lines through here. Okay. I'm actually going to do this and this. And we can say that from D to A is also going to be A. And then from E to O is also going to be B because we're working with a regular hexagon. Okay. So our distance to the center from any of our vertices is going to be the same. All right. So if we're looking from A to D, okay, and Stan is correct. So if we're going from A to D, let me go ahead and highlight the path here. So from A to D, we're actually going backwards. Okay. So from D to A, we can see that we'd go A up this way and also A up this way. But because we're reversing the direction of both of these vectors, we can simply rewrite vector AD as -2a. Give you guys a second here to tell me what vector A to B is going to be in terms of A and B, and then same with A to F. So let's give you guys a second there to confirm in the chat. Okay, so we got negative a plus b for that second problem. That's absolutely correct. So negative a plus b. And let's find out how we got that one. So in this case, we're now going from a to b. So I'm going to go ahead. I'm going to get rid of the yellow here. So we're going from a to b in this case. And because we don't have some sort of path connecting it, okay, we're going to try to find a different path with the vectors that are given to us. So there's nothing that actually connects A to B. So we want to see if there's anything that's been established to help us figure out what that's going to look like. So to go from A to B, I actually have to go backwards towards O, okay, and then up towards B. So we can see in this case that since we're going backwards here, this would now be negative A, and this is still going to be positive B. So negative A plus B is absolutely correct. Okay, perfect. And taking a look at the last one, what do we end up getting for vector A to F? I see a negative B in the chat. Can I get someone else give me a thumbs up if we're feeling good about negative B? Excellent. We've got negative B as our last little step there. All right, so it looks like we're doing pretty good with this. So I'm not going to bother with another example that's going to be similar to this. I'm just going to hop right into the ones with ratios. Okay, so our next question is going to look a little something like this, and typically the hardest types of problems are going to be something to do with ratios or proving that things are on the same or vectors on the same line. Those are the types of questions at that grade 9 level. Okay, so moving on to a question that looks something like this. So I'll go ahead, pop this next one into here. So we have a triangle and we've got a number of vectors that are already given to us. And we're given the midpoint in this case. And we're given two predefined vectors. We want to be able to, oh, sorry, I realized this is slightly easier than I want it to be, but that's all right. We want to be able to, oh, that's not what I wanted. Okay, scrap that. That was the wrong wrong question. Here we go. This is the harder one that I wanted. All right, here we go. Much better. So for this one here, we've got two vectors that are given to us, and we have P on AB such that A to P and then P to B is the ratio, or it can be defined as the ratio 1/3 or 1 to 3. So we have vector O to P is the same thing as K times 3A plus B. So you want to be able to find the value of K. So I'll walk through this first one with you guys to kind of give you an idea of how we would start to solve these types of problems. So looking at our triangle first, we want to be able to label that point P in this case. Okay, so point P is on line AB such that A to P and then P to B is in the ratio of 1/3. Okay, so what we're going to do with this ratio is I'm going to say that 1 plus 3 is equal to 4. So we can define or we can split this line A to B up into 4 parts. Okay, so in this case, A to P is going to be 1/4 of the way through the line, and then P to B is going to be 3/4 of the way of the line. Okay, so that means if I were to split this up into quarters, let's do that there. I could say that P is right here because 1/4, 2/4, 3/4, 4/4. I think my lines are a little wonky here, so I'll split that up a little bit better. So 1/4, 2/4, and then 3/4. Okay. So in this case, we can say, and maybe I'll relabel this just a little bit better, a little bit neater. So this is going to be point P right here. And we can say that this is going to be 1/4 of the way. And over here is going to be 3/4 of the way. All right. Are we all okay with that idea of using this ratio to help us find the distance from P to B and P to A? And that's usually where most students get stuck, I find. Okay, so if you have a question, please let me know before I move on. All right. So we want to be able to find what O to P is going to be. All right. So can anyone tell me what should I start off looking for first before I can do anything else? So I've defined what each part of A to B is going to look like, or line A to B rather. What else do I need to find? What do you think is going to be important to find out? And again, this is the tricky part because you're not really given a lot of information from here. So what can we do with the information that we do have? So here's my hint. We've spent a decent amount of time thinking about line segment A to B. What don't we know about line segment A to B? And that's what we want to be asking ourselves. Well, not necessarily the length, but we're looking for the vector, right, from A to B. Okay. What is vector AB? And that's what we're going to be looking for next. So in that case, we know that A vector AB, okay, because we don't have a direct line from A to B, we need to use the predefined vectors here. So we're going to come back towards O and then towards B. Okay, so that's what AB is going to be represented by. So in this case, vector AB is simply negative. Oops, I had an extra mark there. It's simply going to be negative A plus B. Okay, so hopefully that part makes sense. So vector AB is just negative A plus B. All right, so that's my first step. My next step is to now look at that vector OP. Okay, so I'm gonna get rid of this over here. Oops, I don't want to erase that. So let's look at what vector OP is going to look like. So O to P, there's a couple different ways we can do this, but I'm going to go with the shortest route. So O to P is going to look something like this. I'm going to go up across this way. So O to A first, and then A to P. So to show my work, I can say that O to P, so vector OP, is the same thing as vector OA plus vector AP. Okay, so OP or vector OP is the same thing as OA plus vector AP. Are you feeling okay about that? Now, before we can take another step, we notice that we're missing one thing. Okay, we don't know exactly what AP is yet. Okay, we know that O to A is going to be A, so that's fine. But we need to also define what A to P is going to be. So if we're looking at A to P, so A to P, we know that A to P is going to be 1/4 of whatever vector A to B was, or vector A to B was. But we know what vector AB was. Vector AB was simply negative A, negative A plus B. Okay, so that was what vector AB was. So I can just simply rewrite vector AP as the same thing as 1/4 of negative A plus B. So vector AP is 1/4 of this whole section right there. So now we can progress with what we had originally. So vector OP is the same thing as vector OA plus vector AP. So let's go ahead and make those substitutions. OP is equal to vector OA, which we know is just simply A, plus vector AP, which we have just found was 1/4 times negative A plus B. Let's go ahead and write that down. So plus 1/4 negative A plus B. All right, and at this point, this is where I find, again, lots of students get stuck because you're now kind of looking um, at what you've been presented and you're thinking, well, this doesn't look anything like what I want. So any ideas, right? Because we want to get 3A plus B, we don't have 3A plus B yet. What can I do in this case? What do you think our next step is going to be? Some of you guys might know, some of you guys might not. Take your best guess. What can we do first? So eventually we're going to have that 3A plus B in there. So it's pretty quiet in the chat. So what we're going to do is simply just expand the brackets first. Okay, so we're going to expand those brackets. So that'll be minus. So vector OP is equal to A minus 1/4 A plus 1/4 B. And if I have A minus 1/4 A, we can think of this A as 4 over 4A minus 1/4 A. That gives me 3/4 A, and then plus 1/4 B. All right, we are nearly there. We have one more step left. What can I do to get this 3A plus B? And we can hopefully see now that we're very, very close. What can I do with these two terms in this case? What do I do with them? What does K times 3A plus B kind of remind you guys of? And hopefully what you're thinking is, it looks like we're factorizing, okay? Because that's exactly what we'd be doing. And in this case, we're going to factorize 1/4. So this 1/4 comes to the outside. So what we're thinking is 1/4 times what gives me that 3/4 A. So in this case, we have 3A and then plus B. Okay, so we have 1/4, 3A plus B ends up being my final form for this vector OP. But we were asked to find the value of K. So in this case, our value of K is just 1/4. Okay, so K is equal to 1/4 in this example. Okay, I know we're feeling pretty tired. We're about a quarter to half 8 here. So we'll see if we can work through maybe one more example. So I'll give you guys some time to work through a question that's very similar to it. Okay, so very, very similar to the question that we've just done. So I'll give you a few minutes to work through this one on your own, and we'll see if we can solve this one, feel good about vectors before calling it a day. All right, so I'll go ahead, I'll make this a little bit smaller. And then we can go ahead and get started here. So I'll give you a few minutes to work through this one on your own and see what we end up with. All right, so let's take a look. We'll get this one done and we'll wrap up our session. So our first step is figuring out where point P is going to be. All right. So we're given that vector OA is just 2A and vector OB is just 3B. We have point P on AB such that AP to PB is given in the ratio of 3 to 2. So again, because 3 plus 2 is equal to 5, we can split up the segment into 5 different parts, meaning that AP is the same thing as 3/5, and P to B is the same thing as 2/5. Okay, so our position of P is going to look roughly about here. Let's call this P. And from here to here, we said it was 3/5. And then over here is about 2/5. Obviously, not to scale or anything. All right, so from there, let's go and define some of our other vectors. So our first step is to figure out exactly what A to B is going to be. So A to B is just going to be the same thing as going from A to O and then O to B. Let's go ahead and write out that equation. So vector AB is the same thing as vector A to O plus vector OB. So we can rewrite this as negative 2A plus 3B. All right, so it's going to be a negative 2A because we're going the opposite direction of that given vector. So instead of 2A, it's now a negative 2A, and then just plus that 3B. The next thing that we need to find is exactly what are my other vectors that we need to figure out. So we have O to P, which is what we're trying to find. So let's figure out what vectors we can use to define O to P. So O to P, I'm going to go ahead and rewrite as we have O to P. Vector OP is the same thing as O to A plus vector A to P. So O to P is equal to vector OA plus AP. So you can see here that we have vector, vector O to P is the same thing as 2A plus whatever AP is going to be. So let's go ahead and figure out what AP is. And we can say that A to P is the same thing as 3/5 of the way, or 3/5 of vector AB. All right, and we already figured out what vector AB was earlier. So we have 3/5 of negative 2A plus 3B is going to give me that vector AP. All right. So we can insert that back down into this equation here, 2A plus this 3/5 of negative 2A plus 3B. So from here, let's go ahead and expand that negative 2A plus 3B. So we'll end up with minus 6. We'll have minus 6/5 A. And then now I have 3 times 3, which is going to give me a positive 9. So we'll have 9/5 B. Okay, so 2A minus 6/5 A plus 9/5 B. So hopefully we're still keeping up over there. I know it feels like there's a lot happening. But from there, we're just about 2 more steps away from finishing this off. So let's go ahead and simplify. So 2A minus 6/5 A. So I can rewrite 2A as 10 over 5A. So that's going to be 10/5 A minus 6/5 A. gives us 4 over 5a. So 4 over 5a, and then we'll have plus 9 over 5a, or 9 over 5b rather, 9 over 5b. And that's going to be our almost last step. We're going to factor out 1/5 from both those terms, and we're left with 4a plus 9b. And we can see here that's exactly what we wanted. This 4a plus 9b is exactly what we wanted to see inside the brackets. And therefore, we can just simply state that k is equal to 1/5. So that'll be it for today. I know it's been a pretty long day, some difficult concepts, but hopefully this has given you guys a better idea of how to work through some straight line equations and at least get started with some of these vector proof questions. Thank you for coming out. Thanks again for all the attention. I'll see you guys next time. Well done.